Summertime already begun in Germany and the pool season is opened. Therefore I decided to create a little fun project, a little tool for the pool. So if you ever asking yourself how to put your legs on a swimming noodle while you're riding it, you will find the answer right in this video. Of course, this is a more playful example, but there are some serious requirements that we have to fulfill. The first of all, we want to have a rounded design with floating shapes, so nobody get hurt while using our product in the pool. And the second requirement is that we want to create a model for 3D printing, and therefore we have to design a model that can easily be printed on an FDM printer. And the third requirement is that I want to create a model out of individual parts that can easily be printed and then assembled later on. But enough of the words, let's have a look into the design process using Blender. As usual, I start by configuring Blender for modeling. For this I set the metric system and millimeters as the unit. I adjust the scale of the viewport grid so that the grid is 1 mm. Normally I work with grid snapping and absolute positioning on grid units. To use the grid snapping, you have to use the orthogonal views. To get a better idea of the shape and the quality of the model or the surface, I changed the matte cap settings in the viewport shading. This allows me to quickly detect problems in the model, for example, unclean geometry, flaws in the geometry like zero faces, overlapping faces, concave faces, can lead to various problems during the preparation for 3D printing. I start with the basic shape. Here is a cylinder, which I generate, but without the top and bottom faces. I take 32 segments, less would leave visible edges later in the 3D print, although we will smooth the model. Then I apply the Solidify modifier to generate a ring. I cut the finished model in half and use one half in combination with the mirror modifier. The ring will later be drawn over the swimming noodle, and to give the ring more support, I make two ridges and divide the model into new sections for this purpose. Then I scale two sections to create the ridges. The transform pivot point here should not be median. Otherwise, it comes to asymmetrical geometry structures. Here it is better to place the cursor in the center and then take it as the pivot point. In the next step, I create the extensions for the dovetail attachment. I select the set of quads and extrude them on the X direction. To have a straight surface for further modeling, I switch to median pivot point and scale in X direction with a value of 0. This aligns all the quads at the median X position. The related keystrokes are SX0. Now we can extrude the quads again to create more geometry. Using the orthogonal views, you can easily adjust your geometry to the grid view using the absolute grid snap function. To assemble the parts, I decided to use a dovetail joint. Here I'm modeling the first part of it. And I will also use the geometry to create the counterpart of it. To do this, I simply copy the related geometry from the first part and make the new counterpart object out of it. To give the components a little bit of room, so that it is not too difficult later to push the components into each other, I will later adjust the geometry and leave about 2 to 3 tenths of a millimeter of space. This should be sufficient for a snug fit. But keep in mind, PLA will shrink by another 2 to 3% within a couple of days. For the placement of the legs, I model a nice rounded ergonomic shape. This is where the advantages of proportional modeling in Blender become apparent. I select part of the geometry and scale the attached geometry proportionally. Here we can choose different curve types or select different origin points with the pivot point menu entry to affect the results. With the mouse wheel we can limit the area of effect, and it's clear here you should be careful to avoid modifying fitted structures or structures with fixed dimensions. In order not to use unnecessary material and also to print faster, a shape can always be designed with holes and empty spaces, as long as we don't need this for the structural strength of the workpiece. As soon as parts of the geometry are not needed for the strength of a workpiece, they can be omitted if it fits to the overall design requirements. After I designed the basic shape, I did use the subdivision modifier to smooth the model. Now some detail work is needed, especially in places that have given dimensions, like the dovetail joint. The subdivision modifier smooths the model overall without regard to any details. But this problem can be solved quickly, and for that I just add additional geometry. A few well-placed additional cuts solve the problem. To support the subdivision modifier algorithm for smoothing, you should have equal-sized quads. If you have difficult sections in your geometry, you can use the smooth function in the mesh modeling tools to make your quads more equal and to smooth out your geometry. Because the subdivision surface modifier works in proportion to the size of the geometry elements, like the size of edges, the size of faces, it is the best to make the individual elements more equal and smooth out the mesh as much as possible. To get a nice rounded surface for the ring part, I use the 3D cursor as a pivot point in combination with proportional editing. Looking at Cura at this time, until I loaded the model, I saw quickly that there were some problems because there were some holes in the model. But this is no problem at all, so I go back to Blender and adding additional geometry. Blender supports this very well with several functions like bridge edge loops or grid fill faces. I can also round off the edges of the dovetail connections a bit and use the bevel function in the mesh modeling toolset. To find all errors, we can also use the functions of the 3D Print toolbox, which is an add-on that comes with Blender. Here I use the 3D printing toolbox to show me the errors in my geometry, and then I can use the mesh modeling tools to correct them. I have created my own video for this, and you can find the link here. So after I made the adjustments, I exported again the STL file and checked the adjustments in Cura. At this point I had to use the merge function in the edit mode to clean up my model and get rid of unnecessary geometry. If you encounter strange behavior of the subdivision modifier, or if the subdivision modifier doesn't follow your detailed and predefined geometry, then you can just use the knife tool from the mesh modeling tools, or you can use the keystroke GG to slide edges. I do the slicing in Cura. I show the settings on the right side, and you can just slow down the video speed to see all the individual entries that I changed. For this model I have chosen a layer height of 0.2 mm. The material is PLA plus filament, which is a bit harder and more stress resistant than normal PLA. But it also has to be processed at higher temperatures. I think the component is not exposed to very high mechanical loads, and a filling between 25 and 35% should be sufficient. During the inspection in Cura I noticed that there was a weak point in the connection of the dovetail, and I reinforced the model at this point. The total print time for both parts was about 14 hours roughly. Because I could print the parts one by one and assemble them later, I was able to use an optimal layer orientation for each part. This is very important for strength, especially since the parts are twisted by 90 degrees to each other. So I've been able to use large layers on the horizontal plane with maximum layer adhesion between the layers. After printing, I cleaned the print parts from the support structure. Unfortunately, I found out that I was too much in a hurry, and I set the temperature a little bit too high, maybe 5 degrees. So the support structure was difficult to loosen because it had melted onto the model. But it's a prototype, so you have to take small setbacks into account. Nevertheless, the parts could be put together quite well. All in all, I'm satisfied with the result, and the first test looks successful, but see yourself. If this content was helpful for you, and if you like this kind of content, please give me a like. This will support my channel, this will help me out a lot, and it motivates me to make more tutorials and videos like this. I wanted to show with this video some advantages of Blender when it comes to designing 3D objects. With Blender we have the possibility to combine the artistic approach and cut working techniques. Of course, Blender does not replace any CAD program, but for design studies, especially in the private area, I think it is a very good tool, and I highly recommend that you try it out yourself. That's all for today. Thanks for watching. Bye. Freedom.